right, it is 8:30 right now. Again, thank you for attending. We'll go ahead and just wait one more minute, get started at 8:31, just to make sure everyone has got here if they wanted to be here today. All right, thank you. All right, so let's go ahead and get started this morning. Okay, so I've started sharing my screen. So let's go ahead and get started. Again, thank you everyone for attending this morning. My name is Kyle Lake. I'm an application engineer with Oasis Sales. And today we're going to be talking about PADS Professional and its capabilities for rigid flex printed circuit board design. We're just going to really quickly cover the process of creating a rigid flex PCB design. We're going to talk a little bit about the technology itself. If you're unfamiliar with rigid flex design in any way, we can just talk about that a little bit just to make sure everyone has a good background in understanding the technology a little bit more. Then I'll hop into the tool of PADS Professional to show how we can actually achieve a rigid flex design, create it very easily, and go ahead and create manufacturing output through that rigid flex design. Just a little bit about Oasis Sales if you're unfamiliar. I know that you might not be familiar with Oasis Sales. We have been a premier sales partner for Mentor Graphics for over 16 years, and now we're happy to move into the Siemens Mentor Graphics era as well and continue supporting our customers through offering them EDA solutions for their technological challenges that they're facing. Our team, so our territory for Oasis Sales is the Midwest and the Northwest. We are also dual broadcasting these webinar series with the TriLogic reseller that's located on the East Coast. So if you're in that territory, TriLogic will be your distributor or reseller for Mentor tools. But if you are in the Oasis territory, you can definitely feel free to reach out to me if you have any questions or would like any more info, and I will gladly help you out. We do have webinars. This is a continuing webinar series, and we have all of our archived webinars. If you like what you see today and like to learn a little bit more about some of our tools or our offerings, please feel free to check out our website at oasissales.com, and you'll be able to find all of our archived webinars on there. Before we dive into it, I would also like to point out that save the date for our next Tech Talk. It will be happening about a month from now, May 3rd. And that's going to be on the Constraint Manager and the Constraint Manager workflow and best practices. Constraint Manager is used in the Expedition and PADS Professional flow to enter in all of your design constraints in one particular window. Okay. Also, we have a YouTube channel. We have all of our archived webinars on there. We have small, short videos, so they can be helpful for just finding how to do some certain feature. Again, check out our YouTube channel here. Here's my contact information. I will throw this up once we are done today. Please feel free to take a screenshot of that or write that down and come back to me with any questions or any evaluation concerns that you might have. Always happy to help. Okay, so let's go ahead and hop into our featured webinar. And again, that is for Rigid Flex with PADS Professional. And I would like to point out there is a Q&A box that you are all welcome to answer questions or ask questions, and I will see those as they come up, and I can address those if they're pertinent to what we're talking about right then, or answer them when we're done. Okay, so if you are completely unfamiliar with Mentor Graphics, this just kind of shows what the product offerings are in the electronics design automation space. So there's basically 4 flagship product lines through Mentor Graphics, and we as Oasis Sales can help you on all 4 of these product lines. Expedition is an enterprise PCB design tool used by a lot of large corporations tackling a lot of very complex designs. So if you're unfamiliar with PADS Professional, you'll see PADS as the project-based PCB design. PADS Professional essentially sits between Expedition and PADS. It utilizes all of the Expedition technology, giving you very high horsepower layout tool, but doesn't come with all the wraparound enterprise data management, collaboration, clients like that. If you're from the PADS world, it's a very capable tool that's been around for a very long time. People are using it to do rigid flex designs today. We're just going to show today in PADS Professional a little bit more of the utilities that make it easier to go ahead and complete those types of designs. Hyperlinks is a PCB analysis and verification tool. It is used for signal integrity, it's used for power integrity, as well as EMI checking. So the Hyperlinks family of suites can do essentially any virtual prototyping need that you need in order to ensure success on your first spin of your printed circuit board. And then Valor is kind of like Hyperlinks, except it's on the manufacturing side. It checks for assembly checks, it tests for a design for manufacturing, and make sure your yield is high as possible. Okay. So this is an interesting slide, and I like to highlight this in order to show why people might be adopting flex technology or using flex technology if they already are. This just shows essentially that big red line on the graph on the right-hand side is showing that the average number of leads per square inch on printed circuit boards has been exponentially increasing over these last couple of years, just to show that boards are staying about the same size, but more and more technology, more and more components are being loaded onto those boards. And Rigid Flex can really help you with this in order to meet your critical form factor requirements imposed by mechanical or the use case for your particular product. So Rigid Flex really opens a lot of doors in order allowing you to essentially fit your design into very small form factors that wouldn't be possible decades ago. Okay, so why use Flex? If you're unfamiliar, why would you want to go into the endeavor of creating a Flex design? It just enables technology. It's a technology enabler. It allows you to pack more technology into a smaller form factor and allowing you to maintain a cheaper design by creating a smaller design. Increased integration, there's a lot of increased integration between cabling and the actual printed circuit board design. You're able to incorporate some of that cabling that you might have needed in the past into the PCB design and including it in one project-based solution. Within the Flex environment of PADS Professional that I'll be showing, we do have the ability to look at our board in 3D and see how it would actually fit in our enclosure to ensure that it's going to work as an end product. We also have the ability to just take a look at dynamic bending. You can play around with the bend angles, the bend areas, just to see what's going to work best in order for you to fit inside your enclosure. Also, the Flex capabilities these days. Here's some unique design challenges that are unique to Rigid Flex designs. There are a lot of added risks with handling a Rigid Flex design, and these are just a few examples of what some customers encounter while they're completing a Rigid Flex design. A lot of the issues surrounding Rigid Flex and a lot of the reason that people are apprehensive of undertaking a Rigid Flex design is due to the stack-up. The stack-up in a Rigid Flex design is very unique compared to just a rigid design. You do have to define certain layers in only certain areas of the board, and that can be a very big challenge that is tackled quite well in PADS Professional. Some of these layers include cover layers, stiffeners, and adhesives. And again, these are all unique to rigid flex designs. Bend and folding control, that can be accomplished very easily within the Pads Professional space as well. We have easy ways to fill plane shapes with a hatch design or hatch plane in order to fulfill rigid flex requirements. And then also built into the tool is full DRC specific to rigid and flex areas of the board. Okay. So that can be very important to make sure that you're still adhering to your design rules that you've set up and you're going to output a high quality product. Okay, so just a quick covering on what happens in the flex layers that we define in our board. There are essentially three unique layers that we do have to define in a rigid flex design, and that's cover layer, which kind of forms a protective coating on our flex layers. Bend areas, where it's actually going to determine how much our flex design is going to bend. And then stiffeners, where that's actually the rigid meeting the flex and are bonded to make it rigid in certain areas of that flex design. Okay, so I'll show how we have the ability to go ahead in our Stackup Editor within Pads Professional and actually define these layers on a board outline by board outline basis. So here's just a little bit more information on what it takes to go ahead and set up a Stackup in Pads Professional. So how it works is we first begin by creating a master Stackup. So that is going to include every usable Stackup layer in our design. Then shown down in the bottom right in that little graphic, it shows that we have a rigid flex design. And how this is accomplished is we have 4 or 5 board outlines. We can take that master Stackup that we defined in that first step, and now on a board outline by board outline basis, we're able to go ahead and assign which layers from the master Stackup we want on those particular layers or on those particular board outlines. Okay, so that has typically been a very big design challenge associated with rigid flex. Typically, this was achieved by drawing keep outs all over your board on your flex areas, drawing keep outs to make sure that you're constraining those areas of the board to only use the layers that you wanted to work with. This allows us to go ahead and define the Stackup on a board outline basis and eliminates the need for all of those unnecessary keep out areas. Okay. Some advantage of this technique is when the outlines change, when the board outlines change during the design process, the Stackup does not need to change. It's carried with that board outline property, and that Stackup definition is going to be propagated through any changes that you create in the outline. Okay. Some flex routing capabilities within Pads Professional. We have interactive tools that allow us to really easily create curved traces, and we can also have the ability to use the sketch router in order to implement those curved traces as well. Okay, so if you're familiar with Expedition or Pads Professional, the sketch router is a very easy and quick way to route a big group of nets in high quality all at once. Okay, so we have the ability to import or input those curves while we're using the sketch router on our rigid flex designs. Okay. We also have the ability to go ahead and do post-processing if you want to route your traces manually and in an old-fashioned with no curves. You're able to go in and select those traces once they've been routed and change those corners or angled corners into actual curved traces, so you don't have to be routing in the curve mode. Also, we have the ability to go ahead and put teardrops and curved teardrops in as a post-process as well. All right, just to make sure, I have not seen any questions in our Q&A box. Like I said, please feel free to ask any questions in there, and I'll get to those as necessary. Okay. So there are many design challenges associated with flex, and some of these just as an example, are components too close to a bend, via holes too close to that bend, or missing cover layer pads, or maybe even too sharp of a bend radius. So Pads Pro has built-in DRC that we were talking about that is directly related only to those flex areas on your board. So this can be very powerful to check for those things that you might not be familiar with or might not be aware of in the flex domain that are only required to be checked in those flex areas in your circuitry. Okay, so that was just a brief overview of some of the offerings within the Pads professional space for rigid flex design. Now we'll go ahead and hop into the tool and just work around in some of that. All right, so this is the Pads Professional Designs workspace. If you're unfamiliar with this, there are some good videos on our YouTube channel that kind of highlight some of the benefits and how to work with this workspace if it's unfamiliar to you and that seems interesting. So the first thing I would like to talk about in here is the Stackup Editor. And the Stackup Editor is where we're going to define a stackup. We can import a stackup from existing designs or from other tools and go ahead and see how that's going to work in our design. So you'll see here in the Stackup Editor, we have all of our layers defined in the table on the left, and it's drawn proportionally to the thicknesses and the stackup on the right-hand side. So it's a really good sandbox to play around with your stackup and actually visualize a cross-section of your board on the right-hand side. So like I said, this is the tool that we're going to be using here to define our master stackup. So you'll see we have a 12-layer signal board with a few flex layers here defined in the middle as well. Okay. So we have all of our rigid layers defined in between on the top and on the bottom, and then our flex layers including a cover layer and some adhesives in the middle. To play around with this, you can just right-click on any of these sections and you can insert above or below a new layer, such as a signal layer or a solder mask or a cover layer or stiffener. So very easy to play around with this and edit your stackup to really fulfill your needs in the rigid flex domain. All right, so once we have our master stackup defined, now we can go ahead and use that master stackup to look at our board outlines. So there are multiple board outlines defined on this particular design, and I'll turn this so we're only looking at the minimum contents, essentially the board outlines. So you'll see we have 5 different board outlines defined in this design, and if I double click on one of these, it's going to bring up the properties for that board outline. So you'll see the type of board outline that this top one is defined as is a rigid board outline. We can name that whatever we'd like, and then we can see a stack up layers definition for that particular board outline. You'll see it's showing that we have all of our stack up layers defined for this board outline. If I click on this dialog box, it'll actually show us the master stackup, and now we can actually select all of those different layers we want on this board outline. So very easy to go ahead and assign which layers we want from that master stackup to a board outline on that board outline basis. If we'd actually like to visualize which layers are making up this board outline, I can hit View Stackup, and it's again going to open up that Stackup Editor and only show the layers that we have defined for that board outline. If I select a flex board outline, I again can view the stackup, and you'll see here that we only have 5 of the actual layers from the master stackup defined on this board outline. Again, if I click on View Stackup, now we'll see that we only have 2 flex layers and a cover layer and for both the top and the bottom. All right, so that's as easy as we have to define the board outlines. And again, for board outline creation, PAS Professional does support DXF importing. I know a lot of people still use DXF from mechanical engineers in order to create their board outline. And we also have the ability to create board outlines from IDF as well as step import. We can create board outlines from that. So a lot of options in order to create the board outlines, or you can definitely draw it within here as well. All right, so just to get familiar with this design, we've got two rigid boards here, as well as all of this flex layers connecting the two, as well as this flex area in the top left-hand section of the board. Okay. So PAS Professional does have the ability to view in 3D for your design. So what I can do here is look at the 3D tab, and we'll actually be able to visualize our design in the 3D space. So as of right now, we can see that we just have a rigid design. And in the 3D space, we do have a few webinars covering 3D capabilities and Expedition and PAS Professional. So if you're unfamiliar with the capabilities, I recommend checking out those videos. But we can visualize the entire design in the 3D space. Okay, so right now, you'll see that the board is totally flat and connected to everything. So it doesn't look like a rigid flex design that we have in the real world, but if I want to, I can go ahead and turn on our bend areas. So this will allow me to actually visualize the bending of the flex that we have defined. All right, so once I have enabled the flex bend, we'll actually be able to visualize how drastically those bend areas on our board are actually affecting the stack up and makeup of our design. Okay. What I can do now is I can actually take a look at both the 2D and the 3D at the same time. So if I need to go ahead and, let's say, adjust the bend area that we have defined here in the 2D space, you'll see I can double-click on the yellow area, which is the bend area, and we'll see a couple of different properties. So if I double-click on any object in the design area in PAS Professional, it opens up the properties window. We'll see here that we have a board outline that's defined for that bend area, a bend radius, and a bend angle. So you'll see it is set at 90 degrees, and it definitely looks like a 90-degree bend in the 3D space as well. If I need to, I can go ahead and adjust that bend angle, and we'll see that update in real time. All right, so I switched that from 90-degree bend angle to a 45-degree bend angle, and we'll actually be able to visualize how drastically that has affected this. Okay. Within the 3D environment, we are able to actually run 3D DRC as well. So this can be good for collision detection in the X, Y, or Z direction. Okay. So if I really need to determine how much space I have, I can actually import the enclosure for this design into this tool as well and run a 3D DRC to make sure that there's no height collision issues that we're going to have to deal with. Okay. Within this tool, I have the ability to go ahead and run some measurements. I can measure distances from faces of components to other components. So for example, from that USB jack, I can run it down to this other section of the rigid flex and get a distance between those two. All right, I also have the ability to run a minimum distance check from any component. So from one of these headers, I can select just that component, and then a minimum distance between any other component will be highlighted. And this just gives us a good check. Again, if I bring in a mechanical enclosure into here, I can run those DRCs or measure from the components to the enclosure just to make sure that I have enough tolerance. All right, so associated with the flex design, we also have DRC requirements that we need to go ahead and be cognizant of in the flex realm as well. So in the Pads Professional and Expedition workspace, I have the ability to look at our Hazard Explorer. So our Hazard Explorer is essentially an online and batch DRC review capability. It just gives us all this little window that shows all of our different DRC checks that we have and allows us to actually look at them on a net-by-net basis, and I can click on them and actually it'll cross-probe that DRC violation into our design. So we have all of our normal Hazard Explorer notifications for our PCB design, and then we also have DRC that is associated with only flex designs. So you'll see here in the bend area, I have quite a few trace violations for my different flex areas of the design. So you'll see it gives us a short description that these traces are non-perpendicular to our bend areas. Okay, that looks like what we have mostly. Also, we have traces have corners in the bend areas. So if I select that, it's actually looking that this trace segment isn't a total arcing trace. It looks like it might have some corners in there. You might want to deal with that before going ahead and outputting our manufacturing. Okay, so very easy to go ahead and find DRC violations associated with flex. Within this window, we also have the ability to go ahead and sign off on our DRC issues or fix them, and they'll no longer show up in there. So very easy to generate teardrops for flex, very important as well. It's a very important process to generate teardrops for some of your flex components in order to just increase their reliability and make them stronger of traces on those flex areas. What I can do here is just select these nets. And what I can do is just route and add those teardrops as curved teardrops and generate those here. So we'll see that these trace drops or these traces will now have teardrops, and they should be nice and curved in order to allow a high manufacturing yield on this part of the design. Okay, so teardrops generally used as a post-process for your traces. It does have the ability to, you can generate trace drops or teardrops and then have them refreshed every time you change anything in the design. So very fluid, very easy to work with teardrops in the Pads Professional workspace. All right, so as far as manufacturing outputs goes for this rigid flex design, the very easy way to get this done is just ODB++. If you're unfamiliar with ODB++, it is a standard that a lot of manufacturing houses accept for your board designs in lieu of Gerbers, and it just allows us to go ahead and understand the manufacturing output a little bit easier, in my opinion. So you'll see here we have all of our layers defined, and I can go ahead on a layer-by-layer basis check what I want to be output in my ODB++ file. Okay, so you'll see here that we essentially have our exact stackup that we have defined in the Stackup Editor, and we can go ahead and check all of these boxes in order to output them to our ODB++ file. ODB++ is nice that we have the ability to launch ODB++ inside upon generation of these files. That allows us to review them as soon as they've been generated, view them in an ODB++ viewer. I know people do have issues occasionally actually viewing their Gerber data. This just allows us to go ahead and generate them and view them as soon as we do, very easily. All right, so as you'll see, the board outline came over fine in ODB++, and then in the viewer here, we have a navigator that we can turn off or on all of our layers on a layer-by-layer basis. All right. So you'll see we have the ability to turn off our different flex layers, turn those on or off, and define those, and really understand what's coming out of our ODB++ file very easily. And here we can turn on or off only our flex layers that we have defined. So for example, I can turn that bend area off or my flex areas, and those will highlight in the ODB++ file. Really easy to work with this tool and understand what's being output on your manufacturing process. All right, well, I don't see any other questions in the Q&A box. That's all I was planning on covering today, so we'll hop back in here. If there's any other questions, please feel free to ask those in the Q&A box. Otherwise, here again is a save the date for my next Tech Talk, which will be, I'll be doing a constraint manager workflow and some tips and tricks or best practices for the constraint manager and the Expedition and PADS professional flow. Again, here's my contact information. If any of this looked interesting, you'd like some more information or maybe set up an evaluation for this particular option within PADS Professional, please feel free to give me a call or shoot me an email, and I'll be happy to help you out with your issue or needs. All right, with that, I really appreciate your time. I know this was a quick, short webinar today. I just wanted to make it quick for you, but please feel free to contact me if you need any more information. All right, thank you. Have a good rest of your day.